Hello.
Everyone is watching the wrong metal. For the last 2 years, Wall Street has been obsessed with lithium. They had been obsessed with cobalt. They had been obsessed with copper. They looked at the electric vehicle revolution and said, cars need wires. Wires are made of copper. Therefore, buy copper. It was a logical bet, but it was wrong because they forgot to look at what the most innovative company in the world was actually doing. While the analysts were writing reports about copper shortages, Elon Musk and the engineers at Tesla were quietly redesigning the entire nervous system of the automobile. They realized that copper is heavy, it is expensive, inefficient. So, with the launch of the Cybertruck, they made a decision that shocked the automotive world. They killed the 12-volt battery and they replaced it with a 48 VT architecture. The media called it a cost saving measure. They said it would save copper, and they were right. It does save copper. But they missed the law of physics that comes with that decision. When you quadruple the voltage in a car, you create a new problem, a dangerous problem. Arcing. When you flip a switch at 48 volts, electricity wants to jump. It creates a spark, a mini lightning bolt. If you use copper contacts, that spark melts the switch. The car fails. If you use brass contacts, they weld shut. The car fails. There's only one metal on the periodic table that can handle the arc. Only one metal that stops the spark from burning down the car: silver. In this 4-part market update, we are going to expose the silver switch. We are going to show you why Tesla's move to 48 volts is a Trojan horse for massive silver demand. We are going to explain why Ford, General Motors, and Toyota are rushing to copy this standard right now. And we are going to calculate exactly how many millions of ounces this copper killer technology is going to drain from the global silver vaults. The world thinks EVs are a copper story. Tesla just turned them into a silver story, and nobody has priced it in. Understand the magnitude of this shift, you have to look at history. For nearly 70 years, every car on the road, from a 1955 Chevy to a 2020 Toyota, ran on a 12 VT system. Why 12 VTs? Because it was good enough. It could start the engine, it could run the radio, it could roll down the windows, and crucially, 12 volts is low voltage. It is safe. Can touch the terminals of a car battery, and you won't get shocked because the pressure, the voltage is low, the electricity doesn't jump gaps. But as cars became computers on wheels, 12 VTs became a bottleneck. Modern cars have radar. They have LAR. They have heated seats. They have steer-by-wire systems. They have massive infotainment screens. A 12 VT system is like trying to fill a swimming pool with a garden hose. To get enough power, you need massive, thick copper cables. These cables are heavy. In a modern car, the wiring harness can weigh over 150 pounds. That is dead weight. It kills range. It costs money. So Elon Musk did the math. He realized that if you raise the voltage to 48 volts, you can lower the current by a factor of 4. Lower current means you can use thinner wires. Thinner wires mean less copper. Tesla reduced the weight of the wiring harness by 70%. They saved money. They saved weight. They made the car more efficient. It sounds perfect. It sounds like a reason to sell copper and buy Tesla stock. But physics always demands a payment. And the payment for high voltage is heat and sparks. This is the part that the generalist investors missed. When you increase voltage, you increase the potential for electricity to arc across a gap. Think about a light switch in your house. When you turn it off, you are physically separating two pieces of metal. At low voltage, the electricity stops flowing immediately, but at 48 volts, the electricity is strong enough to jump across the air gap. As the switch opens, it creates a plasma arc, a spark. This spark is incredibly hot. It can reach temperatures of thousands of degrees for a fraction of a second. If the contact points in that switch are made of copper, the arc will pit the surface. It will create carbon buildup. Eventually, the contacts will melt and fuse together. Imagine trying to turn off your headlights and the switch is welded on. Or imagine trying to steer the car and the steer-by-wire relay fails because of corrosion. For a company like Tesla, which is betting everything on reliability, robo-taxi durability, this is unacceptable. They needed a material for their connectors, relays, and fuses that could survive the arc. They needed a metal with the highest thermal conductivity in the universe. They needed a metal that forms conductive oxides. So even if it burns, it still works. That metal is silver. So how did Tesla solve the problem? They didn't put silver bars in the car. They used a specific alloy known as silver tin oxide. Go look at the spec sheets for high voltage automotive relays. Look at the components made by companies like TE Connectivity or Bosch. When you move from 12 volts to 48 volts, the specification for the contact material changes. It switches from copper alloy to a silver. Every time you press a button in the Cybertruck to roll down the window, a silver contact closes. Every time the autonomous driving computer activates the brakes, a silver relay fires. The entire nervous system of the vehicle is plated and tipped with silver to prevent fires and failure. This is not a thrifting scenario. We often hear about companies trying to use less silver. But in this specific case, the transition to 48 volts, physics dictates that they must use more silver per switch than they did in the old 12 VT cars. You cannot thrift safety. You cannot thrift the laws of thermodynamics. So while Tesla saved 50 calves of copper, they added ounces of silver. They traded a cheap, abundant base metal for a scarce, strategic, precious metal. And they did it across millions of vehicles. If this was just Tesla, maybe it wouldn't matter. Tesla produces 2 million cars a year. The silver market can absorb that, but Tesla doesn't just build cars. They set standards. When Tesla proved that 48 volts saves money and weight, the rest of the industry panicked. Ford, General Motors, Toyota, Volkswagen, they're all desperate to cut costs. They're all desperate to increase the range of their EVs. They looked at the Cybertruck and said, we have to do that. And Tesla, in a move of strategic genius, sent a manual on how to build a 48 VT car to the CEOs of Ford and GM. They want the industry to switch. Why? Because it builds the supply chain for 48 VT parts. So now we are not looking at 2 million cars. We are looking at a global fleet of 90 million cars a year, all transitioning from 12 volts to 48 volts over the next decade. This is a standard shift. It is like the switch from AC to DC. It is inevitable. And every single one of those 90 million cars will need the new silver heavy relays and connectors. This is a tidal wave of demand that is completely separate from solar panels. It is completely separate from investment demand. It is a new structural layer of consumption that sits right on top of the existing deficit. So we have the concept high voltage equals high arcing. Arcing equals silver contacts. But how much silver are we talking about? Is it a gram? Is it an ounce? In part 2, we are going to do the math. We are going to tear down a modern 48 VT architecture. We're going to count the relays. We are going to count the connectors. And we are going to estimate the silver load per vehicle. Then we are going to multiply that by the global car market. The number we arrive at is going to shock you. It suggests that the auto industry alone could consume 50 million to 100 million ounces of new silver supply within the next 5 years. The mining industry produces 800 million ounces. Where are they going to find an extra 100 million? They aren't, unless the price goes to a number that makes you dizzy. Stay tuned for part 2. We are going to calculate the true cost of the Cybertruck. If you are just joining us, you have stepped into the middle of a forensic investigation. In part 1, we exposed the physics behind Tesla's decision to kill the 12 VT battery. We explained that moving to 40 allows them to save copper, but it creates a massive problem called arcing. And we explained that the only material capable of handling that arc without melting is silver. But physics is just the theory. We need to talk about the reality. We need to talk about the ounce. Wall Street analysts are currently modeling the silver market as if nothing has changed. They have spreadsheets that assume automotive demand will grow by 2% a year forever. They are missing the Trojan horse. The 48 VT architecture isn't just a tweak. It is a fundamental rewiring of the global transportation fleet. In part 2, we are going to do the math that the analysts are ignoring. We are going to virtually tear down a Cybertruck. We are going to look at the connectors, the relays, and the zone controllers. We are going to estimate exactly how much new silver is required per vehicle. And then we are going to multiply that by 90 million cars. The number we arrive at is going to terrify you. It suggests that the auto industry is about to consume a chunk of silver supply equal to the entire production of a major mining nation. And they are going to do it at the exact moment the mines are running empty. Let's run the numbers. To understand where the silver goes, you have to look at what the Cybertruck actually is. It is the first mass production vehicle with steer-by-wire. In your current car, when you turn the steering wheel, there's a physical steel column that connects your hands to the wheels. If the power goes out, you can still steer. It is mechanical. In the Cybertruck, there's no column. When you turn the wheel, you're just sending a digital signal to a motor on the front axle. It is like a video game. This sounds cool, but it is terrifying from a safety perspective. If the power fails for 1 millisecond, you crash. Therefore, the electrical system cannot fail. It needs redundancy. It needs backup circuits, backup power supplies, backup switches. This redundancy multiplies the component count. Instead of one switch, you need two. Instead of one relay, you need a backup relay. And because it is running at 48 volts to be fast and efficient, all of those redundant switches need silver contacts. Look at the zone controllers. Tesla removed the fuse box and replaced it with intelligent diffusers managed by silicon and silver. These devices are constantly switching power on and off to different parts of the car. High-frequency switching generates heat. Silver creates the least heat, so we are not just replacing a few copper wires, we are replacing a mechanical system with an electrical system. We are turning the car into a solid block of conductive pathways, and every critical junction in that pathway is plated or tipped with the white metal. Now let's try to put a number on this. Historically, a standard internal combustion engine car uses roughly 15 to 20 G of silver. It is used in the window diffusion, the mirror motors, and the basic electronics. A standard electric vehicle uses roughly 30. The inverter, the battery management system, and the charging port add to the load. Now let's look at the architecture. Industry estimates for high voltage contactors and relays suggest a significant increase in silver loading. When you move from 12 volts to 48 volts, the arc suppression requirements mean the contact points must be thicker. You can't use a thin plating. You need a solid slug of silver tin oxide. If we assume the new architecture adds just 20 G of additional silver per vehicle for the switches, relays, and redundant safety systems, and we add that to the existing EV load, we are looking at a vehicle that contains 50 to 60 G of silver. That is approaching 2 full ounces per car. This might sound small. 2 ounces. I have 100 ounces in my safe. But you are one person. The auto industry is a volume beast. And this is where the math gets explosive. There are roughly 90 million light vehicles produced globally every year. Right now, only Tesla is doing 48 volts at scale. But as we discussed, Ford, General Motors, and Toyota have all confirmed they are moving in this direction. Why? Because it saves them money on copper. And wait, economic incentive is too strong to ignore. The whole industry will switch. Let's project out to the year 2028. Let's assume that 50% of the global fleet has adopted the 48 VT standard. That is 45 million cars. 45 million cars times 20 G of extra silver per car. That equals 900 million G. Convert that to ounces. It is roughly 20 ounces on 29 million ounces of new demand. That is on top of the existing demand. That is on top of the solar demand. That is on top of the investment demand. But wait, that is the conservative estimate. What if the load is higher? What if the move to autonomous driving pushes the silver load to 3 ounces per car? Then we are looking at million ounces of new demand. To put that in context, the primary silver mines of the United States produce roughly 30 million ounces a year. This single design change by Elon Musk has created a demand hole larger than the entire output of the US mining industry. We are adding a ghost country to the demand side of the ledger. It is as if a new nation appeared on the map and said, we need 50 million ounces of silver every year starting now. Where does that metal come from? This brings us back to the biggest irony of this shift. Tesla made this move to save copper. They proudly announced that the Cybertruck uses 25% less copper than a standard truck. Wall Street heard this, panicked. They sold copper stocks, but they didn't ask the second question. If you took out the copper, what did you put in to handle the electricity? You cannot conduct power with air. They substituted a base metal for a precious metal. They traded volume for efficiency. They use less metal by weight, but the metal they use must be higher quality. This is the trend of the 21st century. Miniaturization requires silver. As things get smaller, faster, and more powerful, you have to move up the periodic table. You move from copper to silver. Eventually, you move to gold. The auto industry is effectively upgrading its nervous system. And just like you can't run a supercomputer, aluminum wiring, you can't run a steer-by-wire Cybertruck on copper switches. The physics demands the upgrade. So the demand is locked in, the blueprints are drawn, the factories are retooling. Ford and GM are buying the new 48 VT relays. The ghost country of demand is hungry. But what about the supply? If the auto industry needs an extra 11 million ounces, surely the miners can just dig a little faster. Surely the price will go up a few dollars and new mines will open. In part 3, we are going to destroy that hope. We are going to look at the supply cliff. I am going to show you why silver production has been flat or falling for a decade. We are going to look at the byproduct problem, the fact that most silver mines aren't actually silver mines at all. And we are going to look at Mexico. The world's largest silver producer is currently undergoing a political shift that could lock that metal out of the US supply chain. Tesla needs the silver. Mexico has the silver, but will Mexico sell it? The silver bomb has exploded on the demand side. Now let's look at the devastation on the supply side. Stay tuned for part 3. We are going underground. If you have been following this investigation, you now see the demand side of the equation clearly. You see that Tesla has rewritten the rules of the road. You see that 48 VT architecture requires silver to prevent arcing. You see that as Ford, GM, and Toyota copied the standard. We are looking at a ghost country of demand appearing out of thin air, but in economics, demand is only half the story. If I demand a flying car, it doesn't matter if I have $1 billion. If the technology doesn't exist, I can't buy it. The auto industry is about to learn this lesson the hard way. They are sending purchase orders to the mining industry. We need 50 million more ounces of silver tin oxide. Send it now. And the mining industry is looking back at them with a blank stare because the silver isn't there. In part 3, we are going to look at the supply cliff. I am going to explain the single most misunderstood fact about silver mining, the byproduct curse. I'm going to show you why, even if silver hits $100, the miners cannot simply dig faster. And we are going to look at Mexico, the Saudi Arabia of silver, and why political instability there might cut off the supply to Tesla's gigafactories in Texas. The car companies are writing checks that the earth cannot cash. Let's look at the geology. Here's the secret that keeps mining CEOs awake at night. Most silver mines are not silver mines. If you look at the global supply of silver, roughly 72% of it comes as a byproduct. It comes from mines that are primarily digging for lead, zinc, copper, or gold. The miner is digging for copper. He finds a little bit of silver mixed in. He sells the silver as a bonus. It pays for the diesel. This creates an economic nightmare called inelastic supply. In a normal market like oil, if the price goes up, companies drill more wells. Supply increases. But in the silver market, the price of silver does not dictate the supply. The price of zinc dictates the supply. Imagine this scenario. Silver goes to $100 an ounce because of Tesla. But at the same time, the global economy slows down and the price of zinc crashes. The miner looks at his zinc mine. It is losing money. He shuts it down. When he shuts down the zinc mine, he also shuts down the silver production that came with it. So even though silver is at an all-time high, the supply of silver drops. This is the byproduct curse. The supply of silver is held hostage by the demand for base metals. And right now, base metal mines are struggling, grades are falling, costs are rising. So when Tesla calls and says we need more silver, the industry says, call the zinc guys, we can't help you. There are very few primary silver mines left in the world. And the ones that exist are old, deep, and running out of oil. This brings us to the second problem, entropy. We have been mining silver for 5,000 years. We picked all the low-hanging fruit. We found all the nuggets sitting on the surface. Now we are scraping the bottom of the barrel. In 2005, the average head grade for a primary silver mine was roughly 13 ounces per ton. Today, it is closer to 4 or 5 ounces per ton. We have to dig up, crush, and process 3 times as much rock just to get the same amount of silver we got 20 years ago. This requires 3 times the diesel, 3 times the water, 3 times the labor. This drives the all-in sustaining cost higher and higher. So even if the price of silver rises to $30 to $40, the miners aren't getting rich. They are just breaking even on the inflation of energy and labor. This means they don't have the excess capital to explore for new mines. Exploration budgets have been slashed for a decade. We haven't found a world-class silver deposit in years. So the pipeline is empty. It takes 10 to 15 years to turn a discovery into a mine. If we found a massive deposit today, it wouldn't produce a single ounce of silver until 2040. But Tesla needs the silver for the Model Y next year. The timeline is broken. Now let's look at the map. Where does Tesla get its silver? It builds its cars in Texas and California. The closest source of silver is Mexico. Mexico is the world's #1 silver producer. It produces roughly 25% of the global supply. For decades, this was a stable relationship. American and Canadian companies owned the mines. The silver flowed north, the dollars flowed south, but the political winds in Mexico have changed. Government has embraced resource nationalism. They have banned new open pit mining permits. They are demanding higher taxes and royalties. They are threatening to review all mining concessions. This is a strategic risk for the U.S. auto industry. If Mexico decides to hoard its silver, or if labor strikes shut down the major mines, the supply line to Texas is cut. Tesla cannot just call Peru. Shipping from Peru takes longer, it costs more. And Peru has its own political instability. We are seeing a trend across Latin America where governments are realizing that their minerals are their only leverage against the superpowers. They're not going to sell them cheap anymore. If the 48 makes silver a critical material for the transition, Mexico will treat silver like oil. They will organize, they will restrict supply, they will demand a premium. The North American silver supply chain is fracturing just as the demand is exploding. There is one more choke point: refining. Most silver mine in Mexico is not pure silver, it is concentrate. A dirty powder. It has to be smelted and refined. Where are the smelters? Many of them are in China. We discussed this in the last series, but it applies here too. If the ore goes from Mexico to China for refining, it enters the Chinese gravity well. With China aggressively building its own EVs, they have their own 48 VT demand. They are not going to refine that silver and ship it back to Elon Musk. They are going to keep it for BYD. So Tesla is competing for a shrinking pool of Western refined silver, the metal that stays in the Americas. This pool is much smaller than the global total. It creates a regional premium. Silver in Texas might trade at $80, while silver in London trades at, because you can't teleport the metal across the ocean fast enough to meet the assembly line speed. So we have the demand shock. We have the supply failure. We have the geopolitical wall. What is the result? A price explosion, not a slow grind higher, a violent repricing. The auto industry is price inelastic. If a car costs $50,000 and it costs $50 and silver goes to $500, the cost of the car goes up by $450. Does Tesla stop making cars? No. They raise the price by $450. The consumer pays it. This means the price of silver can go vertical without destroying demand. In part 4, the final chapter, we are going to look at the end game. I am going to show you how to position yourself for this auto-driven squeeze. We're going to look at the specific type of mining stocks that benefit from the North American premium. And I'm going to give you the warning about when to sell. The car is electric, the fuse is silver, and the match has been lit. Stay tuned for part 4. We are mapping the profit. We have reached the final chapter of this investigation. We have torn down the Cybertruck. We have exposed the arcing problem. We have calculated the 50 million ounce deficit created by the 48 VT revolution. And we have looked at the empty mines and the hostile geopolitics that prevent supply from responding. The picture is clear. The automotive industry is driving at full speed toward a brick wall. They have engineered a future that requires silver, but they forgot to secure the metal. When they hit that wall, the impact will be felt in every vault, every exchange, and every portfolio in the world. But for you, the investor, this is not a crisis. This is the opportunity of a lifetime. You are standing in front of the wall. You are holding the bricks. In part 4, we are going to look at the end game. I am going to explain the concept of price and elasticity. Why Tesla and Ford will pay $500 an ounce without blinking. I'm going to show you the specific sector of the mining market that acts as the leverage play on this automotive panic. And I am going to leave you with the final strategy to maximize your gains before the rest of the world figures out the secret. The bomb has dropped. Now let's collect the fallout. To understand how high the price can go, you have to stop thinking like a coin collector and start thinking like a car manufacturer. For a collector, $50 is expensive. For a manufacturer, price is relative to the total cost of the product. Let's say silver goes to $500 an ounce. That sounds insane, right? That is a 10 times increase from recent levels. But let's look at the math for the car. If a 48 VT car uses 2 ounces of silver, at $50 an ounce, the silver cost is at $500 an ounce, the silver cost is $1,000. Assembly line because the cost went up by $900. No. Do they redesign the entire electrical architecture back to 12 volts? No. That would cost billions and take 5 years. They simply raise the price of the car to 5. The consumer pays it. The consumer doesn't even notice. To the auto industry, silver is just a high-tech lug nut. It is an essential component that makes up a tiny fraction of the total cost. This is called price inelasticity. It means the buyer is insensitive to price. They must have the metal to finish the product. And because they must have it, the price of silver can go to the moon without destroying the demand. We saw this with rhodium in 2020. Rhodium went from $2,000 to $30,000 because car companies needed it for catalytic converters. They paid it. They grumbled, but they paid it. Silver is the next rhodium, but the market for silver is much, much bigger. But wait, the skeptics say we will just recycle old cars. This is the scrap myth. Yes, eventually we will recycle the silver from these cars, but a car lasts 15 or 20 years. The silver that goes into a Cybertruck in 2025 will not come back to the market until 2040. It is locked away. It is sequestered. We are entering a supply gap. For the next 2 decades, the auto industry will be a net consumer, not a recycler. And as we discussed in our previous deep dive on recycling, recovering silver from complex electronics is expensive and chemically difficult. It is not like melting down a spoon, so the secondary supply will not arrive in time to save the shorts. The only solution is new mining. And as we know, the mines are tapped out. So how do you play this? If you are buying mining stocks, you need to be very specific. The U.S. auto industry is under immense political pressure to source materials from North America. The Inflation Reduction Act gives tax credits only if the materials come from free trade partners. This creates a premium market for miners in the USA and Canada. A silver mine in Nevada is worth 5 times more to Tesla than a silver mine in Russia or China. Why? Because the Nevada silver is compliant. It unlocks the tax credit. It is secure. It doesn't have to cross an ocean patrolled by hostile navies. The strategy: look for primary silver miners with assets in North America. Look for companies like Hecla Mining. Look for high-grade juniors in the Golden Triangle of British Columbia or the Silver Valley of Idaho. These companies are sitting on strategic reserves. In a supply panic, Tesla might not just buy the metal, they might buy the miner. We have already seen GM buy a stake in a lithium miner. We have seen Stellantis buy a stake in a copper miner. Silver is next. If you own the stock of a small silver miner in Nevada and Tesla announces they are buying 20% of the company to secure supply, your stock doesn't go up 10%. It goes up 10 times. You are positioning yourself in front of the M&A wave of the decade. Of course, there's the physical metal. While the miners offer leverage, the physical bar offers insurance. The 48 VT shift is a technological event, but it is happening against the backdrop of a monetary collapse. When you hold physical silver, you hold the only asset that wins in both scenarios. Scenario A, the tech boom. Tesla builds millions of cars. Silver demand explodes. Price goes up. Scenario B, the dollar crash. Inflation runs hot. People lose faith in fiat. Silver demand explodes. Price goes up. There is no scenario C where silver loses. It is the all-weather asset. It is the bridge between the old economy and the new economy. By buying physical silver today at $67, you're front-running the procurement departments of the largest companies on earth. You're buying the inventory that they need to survive, and eventually the price will rise high enough to pry that silver out of your hands. But that price is not $67. It is the price that hurts them. Let's summarize the case. Fact 1. Tesla has shifted to 48 volts to save copper, which requires silver to prevent arcing. Fact 2. The rest of the industry is copying this standard to stay competitive. Fact 3. This creates a new structural demand of ounces or more per year. Fact 4. The global silver supply is inelastic due to the byproduct curse and falling grades. Fact 5. The auto industry is price inelastic and will pay any amount to keep the factories running. The conclusion is inescapable. We are entering a period of structural deficit. The silver bomb has detonated. The shockwave is traveling through the supply chain right now. It hasn't hit the price chart fully yet, but it will. When you see headlines about chip shortages or part delays in the auto industry, next year, remember this video, it isn't chips, it is the silver contacts inside the chips. It is the physical limit of the periodic table asserting itself against the ambitions of billionaires. You have the intel, you know the secret. The 48-volt revolution is here. Make sure you're powered up. Subscribe.